Hi friends, welcome to Unacademy, India's largest learning and teaching platform. Myself Bhavani. Unacademy offers plus courses for Karnataka CET students. Students who want to write CET exam in the year 2021 can subscribe the plus courses. We have two different plans. We have a 12 months plan at the rate of 12,375, and we also have a plan of 6-month plan at the rate of 10,125. You have a comprehensive batch which the portion will be completed within 8 months, and you will also have a Kannada batch which will be dealing with the topics in Kannada language. In case if you want to join any one of these batches, kindly make use of this code BHAVANILIVE, okay, and get the maximum discount. The Champions batch for the year 2021 has already begun from 15th of October. There are different combinations, PCM, PCMB, PCB, and it has, it will complete all the topics, all the syllabus in detail. There will be also a doubt clearing session. You will be given, quizzes at regular basis. So you will have a daily practice papers, etc. So you can enroll your name. The free practice test has already started from 2nd of November. You can enroll your name for this. You can attempt it live, students, and you can try to get a good ranking in CET exams. Students, remember when you go for Unacademy, when you ask for plus courses, you will have a detailed discussion of the topic. Both class 11 and class 12 topics will be done in detail. You will be given quizzes at regular basis, students, for self-analysis. You are also given daily practice paper so that you can practice well, and also you are given full-length mock tests. So single subscription, you will have unlimited access. Therefore, kindly see to it that you are informing your friends, your relatives, brothers, sisters, your own, your neighbors, maybe your own classmates, your juniors regarding the Unacademy and the plus courses, and help the students to get good ranking in CET exam. But while joining any of these courses, kindly make use of the code BHAVANILIVE. You are going to use the code BHAVANILIVE. This will be the code, so that you get the discount, students, and see to it that you will be preparing yourself very well for the competitive level exam. Students, if you haven't watched my previous YouTube session, kindly watch them, and whenever you like the session, you kindly inform, you kindly press the like button, or you press the, you also share the videos among your friends, and also press the bell icon so that you get further notification about my classes. And you can also watch free classes under Unacademy, also special classes. Therefore, kindly watch all those classes. You can just see the link and you can join. Anyway, student, today we are going to continue with the P block element. I had told you that we are going with the P block element. So we will have question number 1 on our screen. Students, kindly go through the question and see what is the right answer. Which of the following statement is not true for halogen? Okay, so which statement is not true for halogens? Option A, all form monobasic oxyacids. Option B, okay, I hope I am audible, students. You can hear me. Can you hear me, students? I hope I am audible. So fluorine forms HOF, HOCl, chlorine, bromine HOBr. Similarly, you have HOI. So all the halogens, as you know, they form monobasic oxy acids, isn't it? We will see option B, all are oxidizing agent. Students, can you see and can you am I audible? And all are oxidizing agent. Okay, all halogens are oxidizing agent. Now we know that halogens can accept electron. You know, if you take F2, it can accept electron, isn't it? It will accept electron from the other halogen and form 2F minus and plus X2, right? All the halogens can readily accept electrons. Students who are watching the session, am I audible? Can you see everything clearly? Okay. All are oxidizing agent. All the halogens has the capacity to accept electron. Fluorine is a strongly, oxidizing agent. It can accept electron. You see here how it forms F minus and X2. So all are oxidizing agent. This is also a correct statement. We'll go to option C. All but fluorine shows positive oxidation state. All the halogens show both positive and negative oxidation state. But fluorine shows always negative oxidation state, isn't it? -1. But then only in HOF it will show +1 oxidation state. Otherwise fluorine shows negative oxidation state. So this cannot be the correct statement. So option C will be the answer. We will see option D also, student. Chlorine has highest electron gain enthalpy. Now if you see here, actually fluorine should have been having highest electron gain enthalpy. If you take the atomic number of fluorine, it is 9. So configuration is 1s2, 2s2, 2p5. So electron will be added to the 2p orbital. Now the size of 2p is small compared to chlorine, where electron will be added to 3p. Since size is small, when you add an electron, there will be inter-electron repulsion. Therefore, chlorine has highest electron gain enthalpy more than fluorine also. Therefore, the right answer will be option C. Okay, we'll go to question number 2, students. Okay. Match the interhalogen compounds of column 1 with geometry in column 2 and assign the correct code. So you can actually go for the answer. Students, just see whether you get the right answer. X, X dash, X, X3 dash, X, X5 dash and X, X7 dash. So you can see here you are given interhalogen. Interhalogen means formed because of two halogen compound. So there are interhalogen. So you need to see the geometry and you have to find out the answer. Okay, do you get any answer, students? Do you have any answer? X, X dash. you can give example CLF. XX3 dash, that will be CLF3, and XX5 dash, that will be CLF5. And example for XX7 dash will be IF7. Now all these are interhalogens, so kindly see which one will be the right answer. XX dash, what do you think? CLF, student? CLF, you know, half, if you want to find out the hybridization, half, isn't it? And then number of electrons are, valence electrons of chlorine 7, so 1, that means 8, so you have 4, isn't it? Now CLF means there is only one bond, so possibly the structure will be linear, isn't it? It will have a linear shape. We will start from CLF3. Half valence electrons are 7 plus monovalent atoms are 3. 10 by 2, that means you are getting 5. So hybridization is sp3d. So you will have the structure like this. These are the hybrid orbitals. Out of 7, 3 are involved in bonding with fluorine. That means there are 4 electrons which are lone pair. The lone pair will occupy these hybrid orbitals. That means remaining is the shape, and you look at the shape, it is a T shape. You can see alphabet T, therefore this is T. Okay, it's T shaped. XX5 dash, XX5 dash, if you can calculate CLF5, half, so you have 7 valence electron, so this will be 12 by 2, 6. So when you say 6 hybrid orbital, they are arranged like this, okay, towards the corner of an octahedron. Out of 7, 5 are involved in bonding. There is one pair which is free, right? There is one lone pair which is present. 5 are involved in bonding. That means you will have a lone pair like this. So you have the structure. This is a square and this is a pyramidal. So XX5 dash will be square pyramidal. XX7 dash, as you can see, it will be 7 plus 7, half into 7 plus 7, IF7, so 14 by 2, 14 by 2 means 7, so hybridization is sp3d3, sp3d3 means you will have no, all the 7 are involved in bonding with fluorine, so no lone pair. That means structure is pentagonal bipyramidal, isn't it? You have pentagonal bipyramidal, so this will be the structure. So just see, students, what is the right answer? Okay, that means option A will be the right answer, isn't it? Go to the next question, student. In which pair of ions, both the species contain SS bond? Okay, so you need to write the structure and you have to find out where do you see SS bond. Students, in case if you have an answer, you can tell me. Start writing the structure. First one, S4O6 2-. Now you know you can write for sulfur only 6 bond. So you have 2 sulfur, right? And you have oxygen, double bond O, okay? Right? There are 2 minus, O2 minus, that means you have O minus, okay? This is also double bond O. 2, 4, 5. So this will be the sixth bond, right? And you have only S remaining. So in case of S4, O6, 2 minus, you have SS bond, correct? Okay. We'll go for next one. S2, O3, 2 minus. Sulfur can have 6 bond, it need to have 6 bond. So you see O2 minus, that means there are 2 O's are in minus form. Okay, so you have S2. So you can see S2O3 2 minus, even this has S double bond S bond, therefore this also has SS bond, isn't it? Therefore option A might be the right answer, but we will check other option also. S2O7 2 minus. So S2 2 minus, so O minus and you have O minus. Okay, S2 O7 double bond O, double bond O, double bond O, double bond O. You can see here 6 are over, only 1 oxygen is remaining. So this will be S2 O7 2 minus. S2 O7 2 minus, no SS bond. See the next one, S2O8 2 minus. So how the structure will be different? The only difference here is 2 oxygen and you have a double bond. Okay, so you have S2O8 2 minus. So students, remember, even S2O8 2 minus does not have SS double bond or SS bond. So only possible answer is option A. Okay, I hope it is clear. Okay, go to the next question. You have to match the compound and its shape and you have to write. Now actually it's easy to predict, a student. XCF6. You see XCF6 means there are 6 fluorine atom, right? Now when I say Xc, there are 8 valence electron, right? Only 6 are involved in bonding. That means there will be one lone pair. And because of this lone pair, the octahedral structure is slightly distorted. Okay, therefore it is distorted octahedral shape. XCF6 has distorted octahedral shape. XCO3. XCO3 means you will have once again 3 oxygen, and you know the oxygen need to have a double bond. 3 oxygen, 1 remain as a lone pair. That means this is pyramidal in shape. So you have the answer pyramidal. XCOF4. Okay, students, if you want you can write like this also. You can find out half 8 plus monovalents are 4, 12, so 6. That means it should be octahedral. So you have Xc, there are 4 fluorine, right? And you have 1 oxygen, right? Okay. Now here also you can see 1, 2, 3, 4, 5, 6. That means there is 1 lone pair. Xenon has 8 valence electron. Out of which 6 are involved in bonding. 1 is a lone pair. So the structure will be, as you can see, square pyramidal, isn't it? So structure is square pyramidal. XCF4, you can see XCF4. XCF4 means half into 8 plus 4, that is 12. So you have Xc, you have F4, and only 4 are involved in bonding. That means there are 2 lone pair. So the structure is square planar. Structure is square planar. I hope it is clear. So A means, you can see option A is 1. A is 1. B is, you can see B is C, third one. So are you getting answer as option C, students? Do you have option C as the answer? Okay. So come on students, try to find out the answer for the next one. Which is the correct statement for given acid? There are 2 acid given. One is phosphinic acid and the other one is phosphonic acid. So you have to find out whether phosphinic acid is monoprotic, whether it is diprotic, or both are diprotic, or are they triprotic. So look at the option and select the answer, student. Which is the correct statement for the given acid? Students, try to find out the answer. Now when I say phosphinic acid, it is nothing but hypophosphorus acid. Hypophosphorus acid. This is phosphinic acid. Okay. Formula is H3PO2. Okay. Phosphinic acid. Phosphinic acid. And when I say phosphonic acid, it is orthophosphorus acid. Orthophosphorus acid. So orthophosphorus acid is phosphonic acid. H3PO3. Okay. Now how do we write the structure? Phosphorus valency is 5. So P double bond O. You have H. You have H. There is one more OH. H3PO2. Okay. So how many proton it can give? It can give only this proton. This is not the one which is replaceable, or it cannot come out as H plus. Only this OH can give H plus. That means it is a monoprotic acid. If you see in S3PO3, it's very clear now. PH, OH, OH, and you have double bond O. So there are 2 replaceable hydrogen atom. 2 replaceable hydrogen atom, isn't it? Therefore, it's a diprotic acid. It gives 2 H plus ion, diprotic acid. So phosphinic acid is monoprotic acid, while phosphonic acid is diprotic acid. You should not consider this H, student. This is only to consider the reducing property. I hope it is clear. Okay, go to the next one. Which one of the following order is correct for bond dissociation enthalpy of halogen molecule? See, bond dissociation enthalpy goes on decreasing down the group. Therefore, the order should have been F2 Cl2, then you have Br2 I2, because as the size of halogen increases, okay, what happens, the bond length also increases and the bond dissociation energy decreases. So this should have been the order, but this is not the order. Order is Cl2, Br2 and then F2 and then I2, because the size of fluorine is very, very small. Because of that, there will be lot of repulsion between the electron. The inter-electron repulsion makes the FF bond weaker. Therefore, its bond dissociation energy is less. Therefore, the order is chlorine, bromine, fluorine and iodine. Answer is option D. Okay. Go to the next one. When copper is heated with concentrated HNO3, it produces. Students, what can be the possible answer? Copper is treated with concentrated HNO3. Copper, when treated with concentrated HNO3, copper nitrate, nitrogen dioxide and water is formed, isn't it? So you have 4 here, this is 2 and this is 2. So answer is copper nitrate and nitrogen dioxide. If the question would have been asked in dilute nitric acid, then you would have got copper nitrate and nitric oxide. This is with concentrated. Okay. With the dilute nitric acid, you are going to get nitric oxide. Nitrous oxide will be the product when zinc react. When zinc react with dilute nitric acid, you get nitrous oxide, isn't it? Among the following, the correct order of acidity. Now, when such a question is asked, okay, among the oxo acid, if it is asked, student, you simply find out the oxidation state. As the oxidation number of halogen increases, okay, acidic character also increases. So this easy to find out. You can see here, this will Cl has H is +1, this is -2. This is -2, +1, so this will be +1. This is -4, so this is +3. This is -6, so +5. This is -8, so this is +7. So happens the acidic character also increases, student. In other words, the stability of the ion increases this way. Okay. This is the order, student, for the stability of the anion that is formed. So this is more stabilized.